Okay, so we're recording and it's picking up my microphone. I'm going to hit mute so that doesn't play. And this is what I'm going to attempt to cover today. Okay. I want to have some fun to start with, and then we're going to do deep dive into what we've kind of done, and we're going to just skim over the top again, but then we're going to go deeper into each one of these topics. And then what we'll be doing is I'm going to give you a homework 4, which is basically a variation on what you've already completed in homework 3. But what we'll be doing is also adding some of these new compiler switches and flags that we'll be talking about. But to start with, I want to have some fun with this thing called the Binary Bible, written by Saint Silicon himself. He was big in the early days of the PC. And it starts off, it's totally tongue-in-cheek satire. If you like religious symbols, it takes every single religious symbol and turns it into something fun. In the beginning, the giver of data, God, generated silicon and carbon, and the system was without architecture and uninitialized, and on this goes. It's very tongue-in-cheek. It's hilarious. I find it very amusing. Everybody in my family thinks I'm nuts because this is totally geek humor. Okay, I mean, it's 100%, and you can't even buy this book anymore. You have to buy it used, but there's enough of them out there. I bought 2 copies, and one of them's actually signed. And the guy's name is Jeffrey Armstrong, and he made his money in the early days doing hardware design. And then he dropped out of all of it and moved up to Portland and opened a yoga studio. I thought that was kind of interesting, but that's fun, hilarious, a bit of history. This next book is a bit unnerving. I'm assuming all of you have some sort of ethical system to which you adhere to, belief system, you can call it religion or whatever you want to call it. This particular book is called What Makes Us Human? And I'm going to scroll down and look at these. What is the truth? You will seek the truth for all your days, and find it when you rest at last beneath the shade of the tree. Sounds obscure, doesn't it? Okay. And it's if you want to design your own religion, I think one of the instructors in the humanities does that. Make your own religion. Use this book. This book is written by an AI agent. So all these little things, how can I stay centered when I am overwhelmed? And you can read that and tell me if it rings true or not. Now, this is how they programmed it. This is GPT-3, folks. What they did is they took all the religious texts of the world, most of them, some of them they couldn't translate or whatever, and they trained the machine on the religious text. And you start getting these little koans. To me, it kind of reminds me of reading the Tao. You know, the Tao is a book of, short little, the thing that cannot be named is not the, whatever it is, the way. I got this book as a curiosity to see what they did with it. And as you read through this, I found it a little unnerving, knowing that it was written by an AI agent. So, does this mean anything in the big picture? Probably not. But I found it as an interesting touchstone in our world of technology from this, making fun of technology, to this, basically creating a religious text that could conceivably be used in some sort of religion. I found that kind of cool, interesting, disturbing. The book has just been released, and it says, how do I keep my faith? So take it for what it's worth. The name of this book is called What Makes Us Human. And I think it was just released, and I got the soft copy so I could read it on my Kindle. And I was expecting something a little more verbose. I was expecting, long-winded essay. And I'm reading these short little snippets and I'm going, this is interesting. Where are we going next when we have an AI agent sounding like a preacher, manipulating your innermost emotions to get you to buy more stuff? Interesting. Anyway, now where we're going next is this. This is the code we're going to work on today. So start typing, get it to work. And let me make it a little bigger. And what this is doing is, this is factorial. This is all it's doing is it's setting the start point, okay? Res is starting off as 1, because can everybody read this as far as what it's actually doing? It's taking res and it's taking I, and it's just keeps multiplying it, starting with base. The base is the hard-coded number, okay, which you will put into your code. The goal of this exercise is you are going to take this working code and turn it into a function and put it in your homework 3 function. Remember the one you did with add me? There's a function in there called add, right? Well, you're going to add another function to that called factorial. So you'll use argv argc. You'll pass that variable into it, and it will print out the number you entered is this. Number added to 8 is this. Factorial is this. Now, warning, we're using integers here. We're not using longs or double longs. So we can very quickly override that, because factorials go up really, really fast, okay? And I use 6 because the number is 720. Everybody know what a factorial is? 1 times 2 times 3, okay, that's all this is, okay? And what I'm going to do today is we are also going to learn about the linker and the makefile, okay? Because this makefile idea, this is the only time I'm going to talk about makefiles, okay? If you load anything off of GitHub, there's a makefile, providing it needs to be compiled. Some things don't need to be compiled. And we're going to learn how to do that today, okay? So this goes to that section of skills that are job, okay? Compile cycle, compiler flags, linkers, and makefiles. Test-driven development should be, but we're not going to go there. What's this? Right, I'm going to make it a tiny bit smaller so I can show you the comments. I want you to notice the switches. Most of these you're familiar with, except this last one, save temps. That guy's name. What's the humanities instructor's name? Remember him? One of the humanities instructors. Oh, I can't remember his name. Who? Redway. He's the one that does the religious studies or create your own religion. I want to send him this book, the AI book. I should send him this one too. All right. Compile it and run it, and it should look. Let's see. So when you compile it now, and if I run it, gives me my number. That's 720 factorial. You're going to modify this so our previous homework. But notice save temps. Now, if I do an ls here, look at all this interesting stuff. We have our C file, which we're familiar with. We have an I file. We have an O file. And we have an S file. What are these? And then when we finish compiling it, we end up with our executable. Okay. So here, I wonder if I can print that page. Probably not. I'll have to do it this way. Let's go with. Okay. Anybody want a hard copy of the code we're working on? And once we compile it, this is what we're getting. Now, in your directory where it says IPYBB checkpoints, don't worry about that. This stands for IPython notebook checkpoints. So when you save something, it goes into that. Okay. So this is the code we're doing. Create a new directory, call hw4 factorial or whatever you want to call it. Okay. And we'll put this code into it, compile it and make it work. We're going to talk about each one of these, the way they work. So here's our source code. And then what happens when we compile this thing? Well, let's use this Linux command called file. And I'm just going to type in fact.i. Okay, it says it's ASCII text. Oh, remember this one? Ancient history last week. We took two old files and linked them together to make it executable. This is a relocatable object, which means we can bring it into another chunk of code and compile it with another chunk of code. Okay. Caveat emptor. Est. There's our compiler source. And that was it, right? Yeah, CIOS. Okay. So let's look at this I. Can you see that in the back, or is it better to be on the white? Either way, okay. If it works for you, it works for me. Okay. All right. We gave it the office. Tighten that in and make it work. Okay. So this is the intermediary. This is like first step when you start compiling. And look at all this stuff that's in there. What's it showing you? All these header files are the things that get included when you compile. Now, if it doesn't use them, it doesn't bring them into the object, okay? That's a fairly modern invention in the world of compilers. If you have a library and it's referenced, but nothing in the code uses it, don't include it. That's an optimization that has brought tremendous speed improvements to this. But look at all this stuff that gets loaded up. You want to see some code that drives you crazy? Go look at this stuff. What is it? Is it written in assembler? Is it written in C? Is it written in C++? It depends. Depends on the library. A lot of these are written in C, okay? Some of them are written in assembler, okay? This is the one we include. But when we include that one, it includes a bunch of other stuff. So your includes include. This has been a problem in the world of computers and compiling for many decades. Rust and Go don't do this. They have a whole different way of handling how you do libraries, okay? So that's a lot of libraries that gets included into, 6 lines of running code, okay? And it's showing you what's happening. So it's actually taking it. This is the first step. The .I happens first, okay? So it's actually going through and looking at this stuff and building it out. Don't ask me to explain it. But that's how many lines do we have? 608 lines of information to actually compile that many lines of code. Okay. That all means something. Okay. So if I quit that one, the next one that gets generated is the .s. Okay. The .s is the way the GNU suite, that's GNU here, compiles. So if I have C source code, the first thing it does is it converts it into that intermediary file. Then it turns it into assembler. If I have Fortran, it creates assembler. If I have Java, it creates assembler. If I have Go, and yes, you could compile Go with the GNU suite, it creates assembler. You kind of see the theme here. So this assembler is the de facto layout of assembly language programming. Doesn't matter what programming language you're coding in, it's going to end up in this .s file before it hits the last step, okay? So if I look at that one, I'll just use, now I'll bring it up in the editor so it'll be a little prettier. Fact.s. Here it is. Now, here's my question to you. Write it down somewhere. I have generated assembler source code. Can I take my assembler source code compile it and make it work. That's kind of what we're going to do a little bit of exploration today. So we are actually going to peel that back the covers a little bit on what's happening with our compile and link cycle. Okay. And the last thing we'll do is the make. So that's a lot of stuff. Okay. And I'll hit Q here. And the last one is our O. Okay. Now, if I do file on fact O, it says relocatable. If I do a file on fact, okay, basically shared object, it's not stripped. It looks a little different because I used the -G on there, but this is the executable file. Okay. So if I run /fact, I get my number 720. Now, if I type in LD fact.o, try to remember that. So I want to give it a different output. So I want to call it fact2.o. Let's see if it says the same thing. Whoops. I just wiped it out. Get to start over. That's what happens when you type too fast. Brain doesn't keep up. Okay, I want to. So what I did is I hit H for history. I created an alias. And I want to run that command 962. So I can type in bang 962 and rerun that command. Okay. So I've now recreated everything. So what I want to do now is make this again. Fact.s output fact2.o. Okay. No, I did ls, didn't I? Or ld. Let's do ld. Whoops. It's not a linker script. I need AS. Now if I do ld on fact 2, I'm getting the same error whether I compile assembler or trying to deal with my compiled object. I'm getting the same error. What's going on here? This is the part that is a little bit, there's really no way to know this unless somebody actually tells you this. The GCC and the G++ will do linking minimally automatically. So if we remember, we typed in GCC and we did our two things and it like, oh, we did AS and we put in our two .s's and then we linked it and it worked. Okay. The GCC actually calls a program called collect2 to do linking if it's within reason. Okay. So your compiler suite will do some linking of the libraries when you compile. Okay. Now, this stuff is weird. It's complex. It's deep. Okay. And a web dev would probably never touch it. But if you are in the world of making new hardware, then yeah, you're going to be here. This is computer engineering stuff, okay? Or forensics for dealing with, you know, bad guys, okay? So now that I've done this, what is it saying here? It's saying in my assembler file, there is no start. Okay, that's default when you have GCC and GCC sees init main, that's where it knows to start putting all the assembler code. Okay. All right. Now let's continue on this road here and take a look at some of these things. And I need to go find my notes. So hold on a second here. Where did I put them? There. Give me a second here. So find my notes that I've written. This is the problem when you work on too many different computers. You forget where you put stuff. Okay. Okay, found it. All right, part of it anyway. All right. Getting close. Oh, I know where I put it. That's where I put it. All right. Here's some questions I would like to have you play with. Okay. And this will be part of your homework. Okay. Now, I'm not going to ask you to try to figure this out. I'm just going to ask you to kind of open the door and go, oh, wow, and then close it. Okay. There be dragons, right? And close the door. Okay. That's really what I'm asking you to just be aware of what this stuff is. Okay. Now, can we do this? Yeah. But there's a whole lot of steps we got to do. Okay. Now, why are we dealing with this assembler stuff? Well, what ended up happening is that the virus we got was a single executable that when we brought it up into the debugger, it was many pieces of object code that did different things. One of them did DNS tunneling. One of them sent the information to the mothership, was in China. And there obviously we're looking at this at the similar low-level code. And I go, what is this? It was definitely a prototype, okay, because there was a lot of mistakes. One of the things that you can do in a linker is you can change where your object points in memory. So I've got this object and this object, but I want them to talk to each other. I can use a linker script to say, go to this address from this address. Okay. Now, linker scripts of that level are way beyond the scope of this class. I want you to know that you can do that. Okay. You can take object from Fortran, C++, even though they're completely different things, you can create a linker script that makes it work as a single executable. And that's what this virus was. Okay, it was a single executable. And what made it gnarly was you found it, you delete it, it'd rename itself, bind itself to another process. And it would use a name that would just pull a random name out of user bin. So you didn't even know what you were really looking at because it kept mutating. It was very difficult to find. We found it, we captured it, and I put it on a disk. And I have not yet even opened that disk because I don't want it to escape, you know. All right, so that's why, okay. And then there's some other fun things we can do here. Here's some of the things. Now, the commands I want to introduce to you today are this object dump, and the other one is nm, as in Nancy Mango, 2 letters. And the other one is read elf. Okay, so let's put those in our notes over here. And we're going to play with them. So I can remove that because that doesn't really matter here. So here, obj dump. Anybody played with these yet? Yeah, I'm throwing you into the deep end of the pool. This is out there. Okay. So this is where I was playing with my code. Okay, I was playing with it in a different place. And basically this is the end of it. Okay, where we can actually dump the code. So let's do that one, object dump on what we just created. Now I compiled it with the G flag, remember? So it's got my debugging symbols in there. Look at that lovely mess. So, quiz from last time we met. Is this Intel or AT&T? AT&T. The default, unless you tell it otherwise, is going to be the AT&T syntax. Okay. And that's what we're using just because it's the default. Okay. This is where your program starts. Remember, linker error, we said, I can't find a start. It's in this BSS register. And one of the things we have not gotten into is what happens when we move these assembler 1s and 0s in and out of registers to make things work. We're getting there. Okay. Well, that's a lot of stuff for object dump, isn't it? Okay. Now let's look at the read elf -a on facts. It gives us something a little different. And what are we looking at here? These are the entry points into memory of where our stuff works. So when you run the program, you run your program, you run yours, we're on a shared machine. Everybody's going to have a different set of memory. It's going to go into a different place. But your code is going to work under your account. So how do we do this without crunching? How do we take relative addresses and make them absolute? Magic. That's part of the operating system. Okay. All right. So that's the read elf. And then nm is the last one. Okay. I forget what that stands for. Man in. Oh, list symbols from object files. Now you can use the NM on any .o. So if I go through and look at my .o's here, I've got two. I can say NM on fact2. There it is. And let's look at the other one. They look the same. Are they? So I've got fact2 is 5872 and 5872. But they were created different ways, weren't they? Okay. This one here is just an intermediary. I said save temps. So the object code is saved, but it doesn't have the executable wrapper on it yet, because our GCC does that by calling the linker script magic. Okay. Isn't this fun? This is obscure stuff. I get it. Okay. Now, the part I want to cover for sure is this thing called a make file. Okay. Go to GitHub, and everybody go to GitHub. Okay. And find some source code you like. I don't care what it is. I'm going to go to one. Oh, didn't save my password. Oh, yeah, it did. All right. Where's my stars? All right. It's called flow chart fun, I think. Oh, let's do that one. That'll work. Here's some source code. I want to install it. This is DuckDB. DuckDB is referenced. Give me a second to bring it up to show you. DuckDB, I put right there. Okay. This is a machine learning stock picking engine that I thought was an exceptional write-up. And it's written about DuckDB, which I just discovered. It's a phenomenal tool. It's got some really fancy things. So when I download this thing and I want to compile it, run make. So you are going to learn how to do that with the source codes that we just did. Now I'm going to show you the make file that they have here. Ready? This is the make file. That looks like another programming language. Kind of is. Okay. We are not going to get that complex. We're going to do a really, really simple one. Okay. And then maybe we'll move on out. Okay. All right. So what does a make file do? Well, in our little world, all we're doing, let's see here, is we run our little command. Whoops, this isn't it. Where is it? I want to go. Oh, I've got a different. Oh, let's do it this way. I just run this and I'm happy. Okay. But what if I had 5 or 6 different objects and I need to link them and I need to do a bunch of different steps in addition to just the compile line? Okay. This is where we can use the make file. Okay. And I've got a nice little easy make file here. I think. Yes, I do. And this is from that Introduction to Computer Organization with the Raspberry Pi, Mr. Bob Plants out of Sonoma State. Okay. I want to find that. Yeah, here we go. Our make file. Now the convention to use make is to have a file name called make file. So we edit this file and we simply call it make file. This is the default. Okay. Now, what do we put in here? Well, we create a make file and it uses comments. Okay. So the comments are like this. So you can say make file to create fact.c. Okay. From fact. How many have written make files? Oh, okay. All right. So we will call it, let's see here. I'll just make it like this, my fact, and we give it this. And then we call the name of the file. Okay. And then our next line is compile. And we'll put the debug symbols in there. And I'll leave that there at the moment. Now, if we use the -save temps, was it temps or temp? Temp, right? We can have another one down here called clean, which goes through and will remove *.o, *.i, *.s. Okay. Whoops. We'll put in the -i here for, it's giving me a syntax error for some reason.
It's temps.
What?
It's an S. Yes.
Louder?
Temp. It does have an S.
It does have an S. Okay, for temps. Okay, thank you. Okay. All right. Basically, what this will do is let's say we'll call this build. Actually, the default should be all. Yeah, let's do it that way. Let's just do it that way. And then that'll make it work a little easier. All right. This is giving me something. Now, it's in the same directory is in there. So if I say make, it defaults to all. Oops, missing separator, line 3. What separator is it missing? Hmm. Oh, I know what I did. I'll put it over here. Oh, there it is. Yeah, this is, let's use this one. Okay, this is a make file for Windows. Okay, and I'll bring it up over here. And this is a very simple make file. Okay, this is what we want to do. Notice it says hello.exe. That's what we have to call it on Windows, because Windows doesn't know to run an executable if it doesn't have a .exe on it. Okay, so we say make all, and what it's going to make is a hello.exe. Then it passes hello.exe, and okay, this is how we compile it. And then we take the object code and it compiles it, and then it removes our object and the executable. So it actually removes the executable. We don't really want it to do that, do we? So take this and modify it to work with your factorial. And I'll do the same thing. And I'll leave that up and move my screen to the other side and play with it. And we'll just call it factorial. Okay. So I'm going to build. This is the kind of stuff that if you don't use all the time, you do forget. Probably better not to use wild cards. Oh boy. Well, let's see what happens here. I am getting an obscure syntax error. Could somebody please Google make file needs tabs or spaces? Because I have my editor to change all tabs to spaces. And the error I'm getting points to that.
Says that.
Tabs? Yeah. So guess what, folks? My error has nothing to do with my syntax. My error is because I'm what? I'm using spaces instead of tab. Now in my editor, I can set it up to say, there we go. So that's showing me that I have spaces, don't have tabs. I'm gonna on that. So that is a really obscure problem that will haunt you throughout your days. Spaces and tabs are treated differently based on who knows what. And I have yet to find anything consistent. Okay, so I'm going to bring my makefile up in this editor and put my tabs in here. And let's hope the tabs actually work. Okay. All right. So when I type in make all or just make, it will build my fact executable. It's going to do 2 steps. It's going to take the GCC, turn it into an object. Okay. All right. And then does C. So basically when it reads this thing, it reads it into memory and works its way back up. Okay. Now let's see if I get the same error with my makefile. Let's run make. Missing on line 5. Missing separator. So what's missing? There's supposed to be a space in there. Missing separator. This is pretty much the simplest you can find on this. We can actually make it simpler. Let's do that. Let's see if we can. This goes this. This goes this. All right. I'm missing something brain dead. Let me. It's easy enough for you folks to do some Googling. So what I'm going to do is do a Google search on makefile, simple, no expansion, because we can put wildcards in here to make this more generic. So what we've just done is we've made this hard-coded to work with just this piece of code. Okay. And so look at it and read up on it, because I see some of you fading off into sleepland, because this is pretty boring stuff. But makefiles You got to know what a makefile is if you're going to use source code off GitHub. You want to compile it, you got to use the makefile. Well, most of it works, and you don't have to look at it until it doesn't. Then we have a problem. Okay. I'm going to fix my errors or attempt to them. Maybe I should just. Even some of the simplest ones, they give you the flags to set. Try to find one without expansion. Figure it out?
No.
Okay. Different question.
Say, we add the SSH or SSH kind of GitHub.
Hmm?
Or SSH.
Oh, yeah. Yeah, this is, yeah, you can do that. That's off topic. But yeah, you can, GitHub will save all your SSH keys. So if you have an Amazon instance or whatever, you can actually have a place for all your SSH keys and then just distribute them.
I just want to see if Jim's possible to connect Jim to the game.
Mhm. Why am I getting that missing separator? Isn't this fun? Yes, sir.
I'm gonna figure it out.
Oh, good.
So you can make engines and then this one.
Oh. You actually get, okay.
Tabs will turn into just like 5 space bars. You do these. Oh, these, I get tab for just a bunch of space bars.
Oh, so it's a tab and a space?
No, it's just like if you hit tab, it's just a bunch of spaces, not actually.
Oh,
tabs.
this editor.
It does
So,
actually tabs.
so how did you embed the tab?
Yeah. Use those tabs.
Okay, all right. I can show you this. In the world of Vim. Yeah, so that's deceiving. What's happening is that this editor is putting spaces in. Why? Jupyter Notebook. Tightly coupled to Python. What does Python do with tabs? It barfs on them. So this editor, no tabs. So let's figure out how to make that work. I'm sure there's a fix somewhere on that. And in this is my VimRC. There's a lot of stuff in here that we don't need, but this is what's happening. Is it's setting tabs to spaces using these. So if I take this out, whoops, the comment is a semicolon for VimRC. The Vim has its own programming. I'm just going to remove those two. Okay, remove anything related. And your VI should put in show spaces. Those are my character keys. Good catch. I would not have thought that the editor does that. How do you know until you know, right? Now it should default to 8 spaces. Ha! Magic. You fixed it. You saw the invisible. Hold on to that. Those are the kinds of things like in certain programming, like the make needs tabs. There's some other obscure programming languages like M4, which is used for send mail. It uses tabs. There are certain things that there's some places. So it works. So if I say make clean, yep, no recipe target. RM hello. How about hello.i? So if I type make fact, defaults to that one. And it says it's up to date. Let's see. Does your clean work? I'm not getting. Oh. Do I have any files called hello? I caught you all sleeping. What's the big takeaway? Make files need tabs, right? Now I can recompile it and just say make. So you can see what it did. And if I run it, it still works. Okay. So there's our working make file. Okay. You can also put echoes in here. And what's interesting is, oh, notice how it goes to Control I. Yeah. I have this macro for my Vim to show me white spaces because I've been bit by white spaces enough times that I remember what it feels like. Okay. There are like HTML doesn't care about white space. Python is really picky about white space. Make files want tabs. Now notice it doesn't matter if the tabs are 4 or 8, it wants tabs. Okay. So now when we save this, I gotta figure out how to get around this on, so if I, let's see, I'll just close it. And then I'll open it. And there's the tabs. I wonder. Oops, that didn't work. All right. I'm going to have to go find that out. How do we put tabs in the editor for Jupyter Hub? Yeah. You figured it out? What'd you do?
Copy and paste it. It worked.
Okay, you copy and paste it from Notepad or another editor that's got the tabs in it. Hey, I'm not above copy and paste. That solves a lot of problems. Yeah, so this is an interesting error. I remembered, but I forgot. Okay. All right. Now, what we're playing with is our GCC and our linker and our save temps. So what if we put this all on one line? We could say, and actually put it down here. Don't need the object. Let's just run that one. Temps. So now when we say, let's just say all, that's the default. You'll see make all and make clean in almost all your make files. Okay. And the best way to describe what a make file is, it's kind of a pseudo shell. It does the expansion. So you don't have to type this stuff in. You can have a boilerplate make file that has a bunch of information in it that you're going to use. Companies like Google or Facebook will give you a make file that you use to build out things. So now that it's here, I'm going to hit save. And now let's go run it. So if I type in make, it compiled it. And I can do my fact. There it is. But notice all my stuff. Now I type in make clean. You can see it removed some of them. I could get in there and clean it up a little better, remove the S and fact 2, I don't need anymore. Okay. So let's go over here and say remove. There. So now when we say make all, it builds everything for us. And it saves all these temp files. And then we run make clean, it removes all the temp files. Okay. You are now experts at make. Make needs tabs. All right. Okay, now where are we going with homework 4? Make file, and you're going to change your libraries let's see here, and I called it mylib dot h. Notice how I have two function calls in my libraries. That's all you're doing. You're taking the factorial that works, we just wrote, and you're going to put it into the dot h. Okay. Here it is. Here's my dot h. Okay. So here's the add me that we did from homework 3. Is this bringing a bell? Yep. That's the idea. And then once it's all done, put a make file around it. So use make all and make clean. Okay. And then I'll do the write-up on it. And I will give you basically this kind of, I'll give you this as a make fail to get started. And then our factorial C looks like this. Okay. You're going to need to pass argv, argc to this thing somehow, just like you did in the add me, right? And that'll be homework 4. Should I give you 1 day? Couple weeks? If I can make it too long, you're all going to forget. Only because I know I would. So we'll make it a reasonable time frame, week and a half or something. And then obviously I'll be here tomorrow. If you want to hang out tomorrow and get the homework done, that'd be great. I'll be here from probably 9:30, 10 to 2, 3 o'clock or later, depending on what I'm working on. So if you come to this room here and you see that back door propped open, 99% of the time I am here, even if these doors are shut. Okay. So you'll have to pound on them really, really hard because it's loud in that back room, but I'll try to remember to prop the doors open. So you remember, rarely do I keep that door closed. Okay. Okay. That's what we're doing for today. Homework 4 is modifying homework 3, adding a make file. And I don't think I want to drill down too much into the linker. I think it's more important that we start knowing how to read the assembler. Okay. Okay, so you've got 15, 20 minutes to play, or you can leave, or whatever you want. You got questions? And help me figure out how to put tabs in the Jupyter Hub editor. You figured out? How? In the Jupyter Hub? That's not SS. That's your SSC. That's something different. You're off topic. All right, let's go here.
For homework 3, you just want screenshots of working good.
Yeah, it was PDF screenshots. And you can do screenshots any way that your machine wants. There's the alt print screen, control print screen, they all do something different.
Thank you.
You bet. And when you put it in Word, to get Word into PDF, there use the export.
Okay,
You say export PDF.
thank you.
You bet. Yeah, that's one of the fixes. simply copy into Notepad and then paste it into Jupyter.
Professor,
Mhm.
remember you said you were gonna see, I got the ACM.
There you go. Awesome.
So now I made an account too.
Good. Now log into the Learning Center.
Oh, let me go back. Here, maybe I can ask you a question. I was seeing something with the edit or the file thing about the tab. If you go to edit
Mhm.
and in there you can do different key map to Vim, you could try and see if Vim will be different. All it does is just like when you click on something, it'll be like similar to Vim. So if you hit tab, since you changed it, it might be, oh wait, you
Yeah.
got out of Vim.
Yeah. Okay. Let's do that.
Did you? No, you weren't. That's weird.
It may very well because
I don't know what Emacs or any of those.
Emacs is the 900-pound gorilla editor. Think of Visual Code 25 years ago. They did everything. You can read email, you can surf the web, you can do everything from inside Emacs. People who are on one computer all day and do coding generally will use Emacs. But if you're sysadmin, DevOps, and you're on 30 different machines a day, you're probably gonna use VI.
Okay.
Okay, I will continue looking at that. I wonder if there's a switch.
That's for like languages. and
Oh,
stuff.
is there a make?
Might be.
Not quite. Is Lua?
No, it's just, I think all it does is just make it recognize the Lua.
Yeah.
So it'll like color the code accordingly.
Yeah. Because the make file that I don't know why they did that back in the day, I guess they actually, because the terminals we had was they rarely had these keys. They had this, and then the terminal was attached to the box, and every single terminal that you worked on had a different term cap. In other words, it mapped the keystrokes differently for each terminal on the same app. So every time you got a new terminal, you had to modify the term cap to be able to use your code.
Yeah, because you.
And that's probably why you got some legacy stuff here, but yeah.
When they were looking at, when I was looking at, there was like some stuff you had to like change the code or something. Or like download something. We were talking about how it's like a problem. But I mean, once you get it in the notepad, you can just copy the tab itself.
Right. And
But
and
it's
then
just
keep it.
Oh yeah,
That's-
it's so like it's hardwired in the code
Yeah.
to change any form of tab that you
Into
put in
spaces.
yourself into spaces for no reason at all.
Okay.
People are asking something about like the creators to like change it to where it's like toggleable, so you can toggle between the two if you desire
Yeah.
and such, but it's just like there is no. Yeah, right there.
Yeah. Oh, Alt 09.
Oh,
Sure enough.
wait, what'd you do? So just
So it's ALT 09 on the keyboard, on the, what do you want to call
oh,
it?
numpad.
Numpad.
Okay, it has to be numpad.
Yeah. Not always. It depends on the keyboard. So what this is doing. Alt 09. Yep. Thank you.
It is.
Alt 09.
Hmm.
This is how we used to do other things like in VI, you can use a similar keystroke sequence to force a form feed. So when you print,
Mhm.
you only want 3 lines, and you say Control V and then Control Enter, right, or Control L. And then what it does is it embeds a funny looking character that looks like an L.
Mhm.
And then when you print it, if you have 6 lines and you put the L between 3 and 4,
Mhm.
it'll be on 2 separate pieces of paper because you forced a line feed to the printer or page feed. So yeah, this is like, how do you embed the smiley face? The same kind of
yeah,
thing. This is all that.
on pads.
Okay, for this to work, you need a numpad on your keyboard. Top row numbers on the keyboard did
Neat,
not
I
work.
didn't see that. Okay. Yeah, no, that's.
Yeah, this is what we want. We want a real tab. Because now
I mean, that's literally the tab symbol.
Hmm?
It's the tab symbol, the arrows that he's talking about, the rather ugly arrows in place of the tab.
yeah,
But
Yeah,
no,
and
it's
we-
actually just the arrow with the
yeah,
line.
it's just like some people don't like looking at that.
It's weird.
Well, everybody's, opinion, and everybody has their opinions about this stuff.
Okay.
And well, that's good to know. How am I going to remember that? Write it down about 10 times.
Yeah. You end up doing the homework 3, the
Mhm.
ARG-V ARG-C.
Mm-hmm.
Could I get some help with it, or
Sure.
I just need to figure out how to solve
Sure.
the core dump? I like searched all over online.
Oh,
figure it out.
yeah. Let me show you.
Like,
Let's see, where did I put it?
I think it's in homework 2. I think it was homework 2X. First? Yeah, no, because homework 1X was the where we fixed it and then run it through GDB to get all sorts of its stuff done. Yeah.
That's an example, but that's not the right one. We want to give you the.
Because I was like,
I think it might be here, HW.
I was very well.
Yeah, this one. This is what I did.
So then, yeah, let's.
Now, what you're doing is your ARG-V, ARG-C, you have 0, which is the name of the program,
Mhm.
and then your first parameter, which is your editor.
Okay.
So you have to have a count of 2.
Okay, because
You're,
you need the title and then what's being entered, and then if it. Okay, so I wasn't understanding then
yeah,
what the ARG-C
yeah, it's actually,
symbols.
yeah,
plus, so
ARG-
whether it was less than or
ARG-C,
equal to.
this throws everybody. ARG-C starts with 0, 1. Okay, so it starts counting the arguments
Mhm.
as logical 0, 1, 2, 3. But the actual number of arguments is still 1, 2.
Yeah, no, I mistook because
That throws everybody.
well, that, and then also I was thinking about like the 1 and 2, whatever you put there.
Mm-hmm.
Sorry, was supposed to be the number that someone was entering, not the
Oh,
actual
count
line.
up. Yeah.
I was thinking like
So-
if ARG-C equals 0 or like nothing, then
Yes.
I don't know. It was.
Yeah, I understand. I get it. Now, what you were referring to is like right here,
Yeah, like that. I thought it was
ARG-V,
similar.
you can do it that way. But this is easier because it's just counting it. And then basically this says, this is how you use it. And it's returning a 1 saying there's an error code of some sort of,
Okay.
as we played with return, you can put anything in there you want. There's anything other than 0 is not normal. So, and then I put it in an else, if else. So,
Okay.
and then basically put this all on one line, so I put it, I'll leave this up on the screen so you
Yeah, I
can see
wanted
it.
to
Because,
check to see what I was doing.
you know, we're weaving together a lot of little pieces
Mhm.
in this class that you may not need right away, but when somebody,
It'll
you're
be
working in
helpful
a
just to know.
team somewhere and you say, oh, have you created a make file and linker? You're gonna look like a god.
You'll just pull this like thing out of your back pocket.
Yeah.
Like this one little
Yeah.
thing you remember. From
Yeah,
school,
it's
and you're
just-
like, oh, hey, yeah, I could do that.
Yeah, I vaguely remember something. Let me go
Huh?
Google it. Yeah. So
Let me
I'll-
get that down.
Yeah, I'll leave this on the screen.
Williams. So I'm right.
Mhm. Go to my ACM. Okay. And click to that one. Okay. And if you're, see where it says member login, that's where you go. Where?
Just need someone to set it, like, you go over there to shut it down. You didn't let me choose my own username, it automatically gave me one.
You can go into your profile and force a change. If you, once you get logged in. Ooh. I need to turn off the recording.